Okay, let's try and get this out of the way. Our next to last one. This is 4.7, and so we should be able to just kind of finish this up and then get going on our last one. So light at the end of the tunnel. So 4.7, trigonometric identities. Recall that an identity is an equation that is true for all real numbers for which both sides are defined. You can see here in the picture, we actually have everything defined up geometrically for all our trigonometric or trig functions. And you can go through and look at these as though they are similar triangles. For example, this triangle right here is a similar triangle to this triangle over here, this bigger one. And if that is the case, then our ratios are all the same, which means that the ratio of sine divided by cosine is the same as tangent divided by 1, which gives us tangent equals sine over cosine. So from this picture, you can actually define all the cosines and all the cosecants and cotangents and secants all based off of sine and cosine right there. Which means we have these right here, our reciprocal identities. Cosecant is 1 over sine, cosecant's 1 over sine, and secant is 1 over cosine, and cotangent's 1 over tangent. And then after that, we can have our quotient identities where we actually define the ratios of them, which is tangent sine over cosine. I just showed you that above. And cotangent is cosine over sine, which you can also do with a similar triangle as well. I believe it's this triangle is similar to this one again now this time, except this angle matches with that angle, and you can basically do it from there. Okay, so let's go ahead and move on here. The Pythagorean identities, the first ones we want to look at here. Conventionally, we have cosine squared of t is equal to the cosine of t, this whole thing squared, but it's not just, don't think it's this. It's not this. Those are not equal. And similarly for sine, we have x squared plus y squared equals 1, and that's from our unit circle, basically saying, hey, here's our unit circle. Take any triangle we want in there. This is the x side, this is the y squared, this is 1, and so x squared plus y squared equals 1. But we also know that x is cosine, so this is cosine squared, plus y is sine, this is sine squared. Oops, I wrote a y. Sine squared theta, and so that's going to equal 1. And so that gives us our first actual identity. It comes straight from the unit circle, and so our first Pythagorean identity is cosine squared theta plus sine squared theta is equal to 1. Now from there, we can start doing a little bit of manipulation, but this is our first one, and the main one you really need to know. The next two just get derived from it. And the first thing we can do is divide both sides by cosine squared. And so we'll divide by cosine squared theta and cosine squared theta. And so here, this will cancel, that gives us a 1, but then we end up with 1 plus sine squared over cosine squared theta is equal to, well, 1 over cosine is secant, so this is secant squared theta, so this is 1 over cosine squared. And then sine squared over cosine squared is just tangent squared, which gives us 1 plus tangent squared theta is equal to secant squared theta. And there's our second one that you should know. And then lastly, we can do the same sort of thing, but this time divide by sine on both sides. So you end up with cosine squared theta plus sine squared theta equals 1, but we're going to divide by sine squared theta and do something pretty similar. I won't go through the whole thing, but you'll basically end up this time with cotangent squared of theta plus 1 equals cosecant squared of theta, and that'll be the third one. So you can do that little bit of algebra. So 1, 2, and 3. Those are our Pythagorean identities. I really recommend that you make sure you know them. Next, even odd identities. If you remember, odd functions meant that f of negative x equaled negative f of x. Even functions, oh, and they were symmetric about the origin. Even functions meant that if you took f of negative x, you just got back f of x, and they were symmetric across the x or the y-axis. And so here we can recall that sine, tangent, cosecant, and cotangent are odd functions, and cosine and secant functions are even functions. And so that means that we can kind of fill this out here. Sine of negative x is going to be negative sine of x. Cosecant of negative x will be negative cosecant of x. Put some parentheses in these. Cosine of negative x is just going to be cosine of x. Secant, which is 1 over cosine, is also even, is just going to be secant of x. Tangent of negative x is going to be negative tan x, and then cotangent will be negative cotangent of x. Okay, so there's those. You don't really need to memorize those as long as you can remember that the two that involve cosine are the even ones. Everything else is odd, and so that's these two are even just because it's cosine is even, therefore secant is even. So really that's the only even one. The rest of them are odd, and you can use that accordingly. All right, next page, using these fundamental identities. So use the fundamental identities and the given information to find the exact values of the remaining trigonometric functions. You can see more of this in the textbook. So first off, we know cosine is 3/5 and sine of x is negative 4/5. So let's start with tangent, because tangent of x we can define as sine of x over cosine of x, and therefore we end up with negative 4/5 over 3/5, which is negative 4/5 times the reciprocal of what was on the bottom, 5/3. The 5s will cancel, and we're left with negative 4/3. So there's the first one. Then maybe we want to try for cotangent of x, because that's just going to be the reciprocal of tangent, right? It's 1 over tangent, since we already have tangent. And so we can just do negative 3/4, just the reciprocal of what's above. Or you could have done cosine over sine, which would have given you the same thing. Next we could do secant. Secant of x is 1 over cosine of x, and therefore it's just the reciprocal, which is 5/3, the reciprocal of our cosine up here. And then we could do cosecant, the last one, and that's just 1 over sine of x, and therefore this is the reciprocal of this, which is negative 5/4. And there we go, we have our last one. So take a look in the book, see some more of those, but they're not too bad. It's just a matter of combining them together until you get it, get what you're looking for. I think I have to go to the next page. Yep. Simplifying trigonometric expressions using identities. So what we have here is this one we want to simplify it and kind of almost like what we were doing with the log, where we want to reduce it down as much as we can. And sometimes how far they reduce is a little bit surprising. So first off, I'm going to go ahead and multiply the two parentheses together. And so I have 1 times 1, that's 1 squared. I have 1 times negative tangent, that's negative tan x, in case you didn't recognize this or what this is going to turn out to be. And then we have tan times 1, so that's plus tangent of x, so those two are going to cancel. And then I have tangent times negative tangent, so that's minus tangent squared of x plus secant squared of x. And if you think back to our Pythagorean identities, I believe the second one was secant squared of x equals 1 plus tangent squared of x. And that means we can go ahead and replace secant squared with that. And so we'll have 1 minus tangent squared of x. And then replace secant here, right? We're going to replace it with that. Get my arrow drawn to the right place there. And so this becomes plus 1 plus tangent squared of x. And then you have minus tangent and plus tangent. And so they cancel. And so we're left with just 1 plus 1, and that's 2. And so this reduced down to just being 2, even though it looked pretty complicated at the beginning. All right, we could try another one here. And for this one, we have the same sort of thing. Again, it's something minus something. It's like a minus b times a plus b. Those are all going to be the same form, which is going to end up being secant squared x minus 1 in this case. And you can multiply the whole thing out and try it if you don't remember that. And then we have a minus tangent squared of x. Now, using the same one as above, 1 plus tangent squared equals secant squared. And again, it doesn't matter that I'm putting theta over here. It could just be an x. That's going to tell me that tangent squared is equal to secant squared minus 1, which means I can have secant squared x minus 1 minus secant squared x, and then it's minus a negative 1. So I could just go ahead and put this all in parentheses like that. And so what's going to happen is I'm going to have secant squared x minus 1 minus secant squared x plus 1. Got to distribute that negative. And so these will cancel, and I'll be left with secant squared minus secant squared, and those will be canceling too, and I have just a 0. So this ends up being 0. So for the next few, I think I'm going to just leave them for you to try, but I'll have them in the notes if you want to look. For this one, it should ultimately equal 1. Just, start distributing, start working with the Pythagorean identities and see what you get. So here, I'll put this up here just so I can remember to do it later. So that should equal 1. Give that a try. This one, I'm going to let you try as well, and I'll have it in the notes for you, is equal to secant of x. Okay, and then last one on this page, cosecant squared minus 1 over cotangent is going to end up equaling cotangent, so give it a try. And again, I'll have it in the notes backed up. And then lastly here, secant minus cosine over sine will end up equaling tangent theta there. And so again, I'll have that backed up and you can try. Now the next one is with trigonometric substitutions. And so we assume that we're between 0 and pi over 2. And what we're going to do is, you can do this sometimes, we can replace the x with tangent in the expression and start simplifying. And so we can do, this becomes square root of 1 plus tangent squared. And then this can become square root of, remember 1 plus tangent squared is secant squared from our Pythagorean identities. And then square root of secant squared is secant theta. Now be careful right here with this part. Do not have that equal. So in other words, don't have this equal square root of 1 plus square root of tangent squared. Don't do that. Don't do this. Okay? Let's make these all capital. Don't do this. Okay? I see that mistake a lot. Don't do that kind of thing. They're not equivalent. All right? We can try another one here, which I think, again, I'll leave for you to try. And again, you're going to have to end up using the Pythagorean identity, but this should ultimately, you should get equals sine of theta. So feel free to give that one a try as well. And that's pretty much it for this section. Again, go look at the notes and see, well, try them first, but then go look at the notes and you'll see all the solutions to these ones that I skipped here in the video. All right, that's all.